Assalamualaikum warahmatullahi wabarakatuh. Today we are going to discuss about chapter 5, chemical bonding, density of water and ice. Let's revise the structure of the structure of water. The water consists of oxygen and two hydrogens, and hydrogen share electron with oxygen. Each molecule of water can form 4 hydrogen bonds. And the yellow one here is the hydrogen bond between water molecules. So what is density? The density is a qualitative manner as the measure of the relative heaviness of objects with a constant volume. We can calculate density by using this formula, mass over volume. So by the end of this topic, you should be able to explain the effects of hydrogen bonding on the density of water compared to ice. So this is a picture of a big ship, a very famous ship called Titanic. So let's see a video of Titanic here. Okay, we are not going to discuss about what happened to Jack and Rose in the Titanic, but we are going to discuss about what makes the Titanic sink. It is because of a big chunk of ice called iceberg. So what are the observations or facts are known about ice? Because ice floats, we can infer that ice must be less dense than water. If water is frozen in a glass jar, the glass jar breaks. From both of the above, we infer that the volume of the ice has increased. This is the picture of the ice jar. It is frozen and it breaks when we take it out from the freezer. Effects of hydrogen bonding on the density of water and ice. The reason ice floats is because of hydrogen bonding. H2O is unusual in its ability to form an extensive hydrogen network bonding. So you can see here the molecules of water moves, and as they move, they actually form hydrogen bond when they are near to each other. But the hydrogen bond will break when they are far away from each other. So in water liquid form, hydrogen bonding pulls water molecules together. As a result, liquid water has relatively compact, dense structure. When we freeze the water into ice, the molecules will become frozen in place and begin to arrange themselves in a rigid lattice structure which maximizes the attractive interaction of the hydrogen bonds. When it freezes, the molecule will become frozen. So it will give rise to an open structure. We will see the structure of the ice after this. This arrangement of molecules has greater volume, which means it is less dense than liquid water, thus water expands when frozen. This is the comparison that we can see for the molecules of water in liquid form, and molecules of water in ice. So in the liquid form, the molecules moves actively move compared to when we have the molecule of water in the structure of ice, which has been frozen here. The molecule in ice, they're actually moving but only vibrating. We can see there are strong stable hydrogen bonds between H2O molecule at 0 degrees Celsius, forming rigid hexagonal crystal lattice structure. This is the structure, hexagon structure, and the blue dotted here is the hydrogen bond between the water molecules. This is what we call open space or open structure of ice. So this open structure of ice will cause the density of ice become less than the density of liquid water. So you can see here the difference on the movement of water molecules in ice and liquid water. In ice, the molecule of water vibrate. But in liquid water, they are moving faster than the molecule of water in ice. So this is a comparison of liquid water and ice density. So let's calculate. The question, what is the volume of 100 gram of ice cube with a density of 0.92 gram per ml? So we have the formula, density is mass over volume. Substitute the values. We will get the volume equals to 108.7 ml. So increase in volume of ice. So volume of water is 100. So 8.7 minus 100 is 8.7. So we have 9% increase. Which is the increasing in the volume of ice. So we can conclude that the increase in volume of ice is about 9%. This increase causes enough force to break most rigid container. So this is what we have discussed just now. If we place the ice, the water in the glass jar, it will break. So from all we have discussed just now, what can you observe from the glass of water and ice? If we have a glass of water and ice, when ice melts, some of the hydrogen bonds in the ice are broken. So this allows the water molecules to be more compactly arranged. The ice shrinks, the volume will decrease and become more dense. The water level will not change as the ice cube melts. So as a conclusion, ice is less dense than water. Ice has open structure which has maximum attractive interactions of the hydrogen bonds and cause it to be less dense than water. The volume of ice is greater than the same mass of water. So hopefully you have achieved the lesson objective, which is to explain the effects of hydrogen bonding on the density of water compared to ice. Thank you.